Well, hello everyone, and welcome back to Adrian's Digital Basement 2. What you see on the bench here are two Crt Driver Boards. You know, I always wonder what they're actually called, but this is the board that would be inside your monitor that actually runs your monitor. Like, it generates the high voltage for the CRT, it does all the deflection, video signal, amplification, cathode drive, all that kind of stuff. Anyways, the reason why we have two almost identical ones here, along with the deflection yoke, is that these belong to David Murray, yes, the 8-bit guy. He is working on a cocktail arcade cabinet that uses a little black and white CRT in it. I forgot which game it is, either like Space Invaders or something like that. And he was having trouble with one of these boards. And from my recollection, he has two of these arcade cabinets, and that's why we have two boards here. And one has a working monitor inside the cabinet where you have a good picture, and the other one doesn't. Now, this is the one he's been having a whole lot of problems with. I've gone ahead and marked it as a number 2 right there, just to differentiate it from the number 1, which is the working one. Now, over the last few months, I've given David a couple tips and pointers on troubleshooting the non-working board, which is this one right here. And he's even gone as far as to remove this board from the arcade cabinet and take it to an arcade or a monitor repair person in the Dallas-Fort Worth area. Just looking at this board, I can tell that it has been recapped. So if we compare it to this one here, the caps are original on this board on the right, but on the left here, they're recapped. And otherwise, everything seems to be intact. Now, David reported that this thing had a picture, like it generated a picture, but it was really not looking good. It was like very bowed in, and the picture was rolling. And no matter how you adjusted these controls on here, you could never get it to actually lock on. Now, my advice to anyone who's working on a board like this trying to repair it, especially if you don't have schematics, is to go over the board and check all the semiconductors using your multimeter to see if they are shorted. So diodes is a good example, and also check your passive components like your resistors to make sure none are open, because that's not an unusual failure mode of a resistor to just go open entirely. And you can imagine this. The video signal, and this uses composite video by the way, it comes into the board, and there will be a circuit that removes the sync signals from the video, the composite video, and sends it to the appropriate sections of the board. So because it's had a rolling vertical sync issue, it could be as something as simple as an open resistor between the video section where it's stripping that sync signal out and the vertical deflection circuit in this monitor. Now, David had gone over every component on this board like I had mentioned, and everything seemed to check out. And obviously it's been recapped as well, which I kind of recall him saying that that fixed some of the issues, like the bowing picture was now corrected, but the picture continued to roll. So when he brought this to the repairman, the guy who is an experienced guy, he didn't actually test anything, but what he did tell David was that this one IC down here that's mounted on this heatsink, which is like a combo IC that sort of does a bunch of things. That's my crappy explanation. The repairman said that that was the problem. So this is the circuit in question, and it is the TV vertical deflection system. So it's kind of a single circuit that does it all: vertical synchronization, oscillator, sawtooth, shaper, vertical output circuit, clamping circuit for the blanking pulse, and temperature compensation as well, just to make sure that you have a really good vertical lock. So David on the phone told me that he desoldered this chip from here, and he actually went online and found a source of some new ones. And here is one of the new ones right here. And it's actually a Samsung part like the one we were just looking at. And the original one is this one right here, which you can see is an NEC part. And you can tell that, I don't know what's going on here with the heatsink, or like the part that goes on the heatsink is very blackened. Now, I don't think that's necessarily burned. I think this is some kind of corrosion. And the problem is, as you can see, this metal tab actually goes inside the package, and the corrosion can creep along the metal and actually break the hermetic seal of the package, which can cause it to fail over time. Now, we can tell from David's description of this part that it was partially working, and that's because this generates the vertical deflection itself, but it also handles the synchronization of the vertical sync to the video signal. And while it wasn't locking on to the vertical sync from the video signal, it was generating the deflection because you had a full picture. You did not just have a line across the screen. So what happened is, after David replaced this part in here, he said he powered it up and it did not work at all. And he said immediately he could smell a burning smell. I don't remember if he said there was any smoke coming from it, but he unplugged it, turned it off. So he gave me a call. He asked me if I could take a look at it for him because he was just at the end of his rope. He had spent so many hours trying to get this board working and was just not having any success. And I said, sure, no problem. So I asked him to send the working board along with the non-working board so I could compare them if some other component on here is bad. And I also asked him to send the deflection yoke off of one of these boards because you cannot run these without this. This is an integral component of the entire circuit. The horizontal deflection circuit on a CRT in conjunction with the flyback and the deflection yoke is a tuned circuit, and you need to have a deflection yoke that's basically the right one for the monitor or things may not work properly. There's probably a certain amount of leeway you can get with the deflection yoke, and like I might have had the right one in the basement here, but it was a lot easier if he just popped this off the monitor, sent it to me so I could test a lot easier. Now for powering this up, this thing has an integrated power supply, which is this part of the circuit right here. You can kind of tell there's a giant heatsink here, a large power resistor. We can see 4 diodes right there, which is a bridge rectifier. Plus there's a lot of discoloration on the board from heat, from running for a long time. So because there's a bridge rectifier, that implies that this takes probably natively an AC input signal. Just for simplicity, the original power supply inside the arcade cabinet would have been a big transformer with some different taps on it. It's just like the Commodore PET, to be honest. It uses a very similar setup. So it just needs a DC input, but of course it has a facility to take the AC signal and regulate it down to the B+ voltage. And I can see there's a potentiometer right there for adjusting the B+. So let's get to some troubleshooting. I'm just gonna move the working one out of the way here. And let's just take a quick look at this board, see if anything has gone catastrophically wrong that is obvious. Okay, so let's compare these two parts here. So the original one here is the NEC PC1031H1, and there's the Samsung part that he got as a replacement. Now I haven't looked up the datasheet for this original NEC chip here. Let me just quickly do that just to double check that it is actually a drop-in replacement. All right, some datasheet checking there, and yes, absolutely, they do appear to be the same. Pinout looks the same, everything looks compatible between these two parts. Now, from a troubleshooting perspective, David said that before he replaced that part, this board was working except for the vertical sync issue that I already described. So the most logical thing to assume is that something is wrong inside this section. Like maybe the part he installed is the wrong part. Maybe there's a short circuit back here when he did the desoldering and resoldering. So let me just do a quick inspection here. Yeah, I'm not seeing anything wrong here. I don't see any immediate shorts. Everything looks completely fine here. I can definitely see where the caps have been reinstalled, but nothing looks out of the ordinary here. Incidentally, you see that black wire that's on there? The other board has it as well. And oh yes, by the way, there's a corner missing on the original board. Apparently that was broken already in the cabinet. So this green wire here was installed to replace the broken ground plane that goes around the corner here. But it doesn't look like any other trace. No other trace was affected. It's just this ground that runs around the edge of the board. So that's a perfectly acceptable fix. All right, now let's see. Looking at the top side here, let's try to move this stuff. Does anything look out of the ordinary? Okay, I am seeing an issue. So this is the original part, this NEC part. There you can see is pin 1. It has a little dot and it has a stripe painted on the package as well. Now the Samsung one here, which looks like it might be rebadged because that looks like pretty nice shiny laser etched writing on there as opposed to the printing that would probably have been on there. So who knows, this thing came from, I think, eBay or AliExpress, so it's probably been rebadged. But the original stripe that might have been on there is gone, not to mention there's no particular dot. So what is pin 1 exactly? Well, in absence of a stripe or a dot, I'm going to say that the beveled edge, which you can see it's far more beveled on the left side than on the right side, I'm going to say that that is pin 1. So that means the way that these are sitting right here is basically, the same orientation. When you're looking at the label, the pin 1 is going to be on the left. Now it's probably going to be very difficult to see, but there's actually a pin 1 silkscreen marking on the PCB there, and it is to my right. I think I'm going to struggle to get the focus right, but you can see there's the Samsung part. You can see the writing is facing us and that notch is towards the left on the picture. But look at the silkscreen marking there. You see it says 10, and on the other side, there is a notch and a 1 printed on the silkscreen marking, which would indicate that that part is in backwards. Now, I can't say for sure if having that in backwards was going to damage that part or not, but the problem is looking at the pinouts on the datasheet for that part, it connects directly to the flyback, which is connected to this connector right there on the board. And hopefully that didn't send a ton of current into the flyback, which might have potentially caused some damage to the flyback. Hopefully not. Hopefully that's a robust part and all that got damaged was that. So let me remove that part from this board and let's see if this thing can work with this new replacement part. Okay, there it is. I just have to take it out with the heatsink because these caps right here are in the way of unscrewing this part from the heatsink. So let's get that off there. Now it looks like David installed a little bit of thermal compound on that one. Let's put the other one on, but we're gonna flip it around. Let's put this back in. Oh, it's getting compound everywhere. Gross. All right, there it is with the part reversed in its positioning. You can see right there on the PCB, there's the very clear pin 1 marking. And that fits back in the board perfectly. So I'll just quickly resolder all of the points back here. Now the reason why I'm using my desoldering iron to actually solder this back together is because it has a very high thermal mass. So for these heatsink connections here, it's really easy to use this as opposed to my my little pine sill soldering iron. That thing is not well suited for things with a lot of thermal mass. All right, there we go. It's pretty warm because, like I said, I put a lot of heat into it. And now we can see that the notch is over here on this side, facing towards the 1 on the PCB. Now I am curious with these two. Let me grab the multimeter. You know, I should have done this before I put the new one back in. But let's just see if we see short circuits here on this, the one that was in backwards. I'm gonna put the multimeter here on diode check. And let's just see what we see here. Doesn't appear to be dead shorted. At least none of the pins that I've been touching here. And I do see diode drops and stuff like that across the various pins. All right, well, anyways, that looks okay. Let's just see how this one looks here. I think pin 2 is the voltage input pin. Yeah, it's very similar. I see diode drops. Like between pin 2, pin 4, I see 0.75. And on the Samsung one, pin 2 and 4, 0.76. Yeah, so very similar. So quite possibly this one that was in backwards is probably fine, but you know, better safe than sorry because we have another one. Let's see if that works. All right, for testing, I have this Philips Magnavox, whatever, Amber 12-inch monitor. It's gonna have a CRT that's a little dim, but it should work perfectly for testing out with this board. I didn't ask David to send the original because that would have been heavy and potential breakage and stuff like that. So better off just, you know, sending the boards and the deflection yoke like I asked, and then we'll just connect this thing all up. It's a pretty long high voltage cable here, and that's because most likely the CRT is mounted in the cabinet in a certain way where this board is like off to the side and like mounted on the wood or whatever. So that's why you have plenty of length. Look at all these cables here are quite long. We're not quite ready for powering up because there is a ground lug on the CRT connector. It is right here, and that would have had a black wire or a cable that ran from this over to the band here or the DAG ground or whatever was on the original CRT. So I do need to get a clip lead or something. I'm gonna clip right here, which is actually where the original monitor electronics connected to. There's a little terminal right there. I'm gonna connect from there to there. Now I will add that sometimes these boards actually have a connection on them and you'll see like a similar metal post that would go from here also to the ground, but I'm not actually seeing that. Oh wait, and right here, CRT earth. So there's a second connection I have to make from there also to this point. Now please, if you're ever working on a CRT, and please only do it actually if you know what you're doing around these high voltages, this is probably like 10 to 12,000 volts right here while operating. Do not ever operate it without these ground leads connected. These absolutely have to be connected for safety. From my understanding, if you don't have these ground leads connected and you power the monitor up, the CRT outside this matte surface here, which is the DAG, can end up at a very high voltage potential, which can cause arcing between that and the electronics itself, which can cause components to be blown out or whatever. So really do not ever operate it without those hooked up. For powering up this monitor, I'm going to use my DC power supply here. The reason why DC works on AC is because the monitor doesn't need any negative voltages. It just quickly converts or rectifies the AC into DC, and then it uses a voltage regulator to create its B+. So all you need to do is give it DC voltage, and of course the polarity, it does not matter because it has a rectifier. So whichever direction you hook it up, it's going to send the correct polarity into the voltage regulator, and I'll be able to monitor the current draw as well on here. And the only thing I do not know is what voltage the monitor is expecting. So what I'm probably going to do is start at a sensible voltage, like around 12 or 14 volts. And then if it's not running, then I will go up little by little, keeping a close eye on the current draw. And as I had mentioned, there's a terminal right here where all this discoloration is. That's the AC input. So I just need to hook my 2 test leads up to those connections right there. And unfortunately, these clip leads, these are crap and they're not working. I'm gonna have to use something else. Okay, much nicer. I found some that plug into power supply that are alligator clips, or crocodile clips as they're called in some places. And to initially see if this monitor is working, I'm going to use this app here called Spectroid, which is just a free app in the Android App Store, which is super useful for testing monitors. The reason why is, at least on my Pixel 6 here, it is able to, let me zoom in over here, it's able to go up to about 25,000 hertz with the built-in microphones on the phone. And you can basically tell if the monitor is running because it has an internal oscillator that this is an NTSC monitor, should run about 15.7 kilohertz. Well, same with the PAL one as well, which will create a big peak, which will be very visible to us to know if this monitor is actually running. Now that 15 kilohertz sound is what you can hear if you have really good ears, but I'm in my late 40s, and even though I protect my hearing with earplugs at concerts and things like that, I can't really hear it very well anymore. It used to be very loud as a kid. So I always rely on this app to see if a monitor is working. And it's really useful because, like a Commodore PET, it runs at 22 kilohertz, which I don't think many people could hear even if you have really good hearing, but yet it shows up clear as day on here. So we'll keep that running right here. And in fact, I'll just zoom up to the upper ranges. So there we go, it's 10,000 and 20,000. So we should see a peak in there when this thing turns on. And I guess I'll position the camera like this, so if any smoke is let out, which I hope it's not, please no, then we'll see it. All right, so I'm turning the power supply on. I'm starting at 14 volts, and I'm gonna start, let's see, why don't we start at 560 milliamps? That's enough. And I know you probably can't even see these numbers because the multiplexing and the camera is just, it looks bad. But it's 14 volts, 560 milliamps, and I'll reposition the camera before I turn this on, and let's see what happens. Well, okay, I think it's running. So what happened just there is the power supply, it went to current limiting mode for a second because the capacitors were charging, but then it actually settled back at 14 volts at about 400 and something milliamps. And I saw a peak on the phone. So let's try that again. Now I paused it. It seems to be running at about 14 kilohertz right now. So that's too low. But there's going to be a horizontal hold, which is this control right here. And I'm going to hit play again and watch this. I'm going to adjust this and it's going to move that. See? Let's zoom in a little bit. So see the purple line there? When I turn this control, it moves back and forth. Now, the thing is, this monitor is currently running in free mode or free oscillator mode. So there's no video signal going into this for it to even lock onto. It's generating its own oscillations. So what I need to do is get a video signal into this thing, and then let's see if it locks in, because 14 kilohertz or whatever, that's not good enough for an NTSC signal. Well, anyways, let me get a test signal, but there was no smoke, no weird noises. I could hear the sound that the monitor was making. I'm assuming we had high voltage. Why don't I test that before I even bother with the video signal? Okay, we have way insufficient voltage here. We're getting 2,000 volts. That is not enough. Okay, that is interesting. That may well be because there is just not enough voltage here. So I'm gonna turn this up. Okay, I've turned it up to 16 volts. No, we're still at 2 kilovolts. So that is not really enough for a working monitor. Now I have to wonder, why is the high voltage so low right now? And the monitor still is running, it's around 14 kilohertz. That's just not fast enough. Now, the part we changed was strictly a vertical oscillator part. It had nothing to do with the horizontal oscillator whatsoever. And the horizontal oscillator is what generates the high voltage on a monitor like this. All right, I've repositioned it here so we can see the front of the CRT. I have the power, everything is connected. Video signal from my pattern generator is connected in here. And it's on. Let's turn the monitor on. Okay, we're getting what we expect, 450 milliamps at 14 volts. Now, when I raised the voltage, it didn't seem to change anything. I could see the oscillator running on my phone. It wasn't changing the frequency or anything like that. All right, so there is a little bit of an image visible. It's like that big right here in this little section. And if we turn this off, there we go. We do get a dot there. And we turn it on and it takes a while. And it's the reason why it's all turned is because, of course, the deflection yoke is incorrect here. Let's turn this. If I turn the controls, it does have an effect. It looks like there's some deflection actually happening this big here. What do these controls do? Anything? Nothing really. When you see that on the camera, let's see. Yes, you do see, you just see that. Let's try to create a little shade over the CRT. Now let me just try to adjust the voltage a little bit on here. I'm gonna raise it up. All right, it's having a little bit of an effect, isn't it? Well, it certainly seems to be running better. So looking at these caps on the good board, they're 35 volt caps. And I'm giving this thing 14 volts. When it goes through the diodes, that's only gonna turn into about 12 volts, you know, because there's voltage drop. It's going through 2 diodes before it gets to the regulator. Not to mention then there's regulator circuit, so there's even more voltage drop. So it's quite possible the 14 volts DC that's going in here is just not enough. And definitely that seemed to be the case. As I turned it up, we ended up getting a much brighter picture, and I started to actually see the crosshatch pattern that I am sending into this thing. So I'm gonna set this for 1 amp, and I'm gonna raise this up. Let's see, it's at 19 volts. Certainly looking better, but I don't really know. Let me show you what's on the screen right now. Look, we have something that is much more akin to an image. All right, vertical size, vertical linearity, but the horizontal hold is absolutely not locking on. And the phone confirms it's running at about 14.6 kilohertz at what we see here, and the range is just not enough. With the control turned all the way to one side, the phone indicates it's running at 15 kilohertz, so it's getting close, and the image is certainly getting better. But unfortunately, when I turn the deflection yoke to the correct orientation, so the picture is correctly aligned here, it's still very bowed in on the sides, which would kind of indicate that whatever problem with the bowing existed on this board is still happening, unfortunately. All right, I'm gonna kill the power on this. Bloop, there it goes. Let me hook up the other one, and let's just see if they act any different. All right, the working board is connected. I've changed the power supply back down to 15 volts. We'll start there. Let's power this up. Okay, this is only going at 300 milliamp. All right, it's running at 15.3 kilohertz now, although there's no image. Let me turn the brightness and the contrast all the way up. Yeah, nothing. All right, it's now running at 16.1 kilohertz. So there's a lot more adjustability in the range here. There, now I'd have it at 15.7. But why is there no image? Let's power this off. We don't get anything on here. Let me double check what I have going on here. Earth connection's connected. The video signal is definitely connected. Neck board's on, ground's connected. Yeah, everything looks to be correct. Let's do the old high voltage probe here. Let's see if we're getting a more appropriate high voltage. All right, and this thing is running at even lower voltage. It's at 500 volts. That would really explain why we don't have a picture at all. I mean, 2000 volts, that's kind of on the fringe of working, but 500 volts, I think I saw between 1000 and 500 volts, not enough. All right, so the question is, this thing is off right now. Why is this thing running at the right frequency, so at 15.7 kilohertz, you know, with the horizontal control, but is generating almost no high voltage? The only thing I can think is that the deflection yoke is part of the problem. Now, I mentioned this earlier, the deflection yoke is a tuned part of the circuit that definitely is necessary for high voltage to be generated. If I unplug the deflection yoke and I turn on the monitor, you're gonna get a little bit of high voltage, but barely any, because like as I said, it's a big inductor and it's necessary for proper operation. The other thing I noticed is that even at 20 volts, this particular monitor board was only pulling about 500 milliamps and the other one was close to 1 amp. Not having the original cabinet with the original transformer hooked up to these boards means I don't really know what should be running. Now 20 volts at 1 amp, if that's what was really going into the other board, is about 20 watts, which seems a little bit high. I think that's a little bit more than it should be. Although when you have this type of voltage regulator that's basically bleeding off a bunch of the voltage into this heatsink, in that case, that doesn't seem that bad. I'm gonna have to do a little bit of thinking, a little bit of reading, and I'll be right back. We'll see if I can figure something out with these boards. Well, it's the next day, and let me turn on the power supply up here. Let's see what happens on the screen. Would you look at that? We have, if I switch this, a good looking pattern. It's actually totally working. And yes, indeed, this one that's right here is the one that had the IC that was backwards. This is the one here that was the working one. So let me grab a pointing stick and let's take a look at what I did to make this thing work. I'm gonna use the other board here to point to things because it'll be a little bit easier. So as I mentioned previously, this here is the power supply for the board and the AC voltage comes in on these two pins and it gets rectified, then it goes through this resistor here, and then there's a little bit of a voltage regulator happening here. So one thing I actually did on this board is I connected the DC power supply, which is still these two wires taped to the top of the monitor here, and I put them directly into the board, bypassing the bridge rectifier. Now, why did I do that, you might ask? Well, because obviously when you have an AC waveform going into the power input here, these four rectifiers are sharing the load as the AC waveform goes through its, I don't know, up and downs, let's just call it. Well, obviously when I'm putting DC into it, it's putting more load on, I think, 2 of the diodes, or is it just 1 of the diodes actually? Looking at the bottom of the board allowed me to figure out the way it all works, at least from a power supply perspective. The bridge rectifier gives you a ground and a positive voltage, right? And the positive voltage then goes through that fuse, which we saw right here, and then it goes through these capacitors right here, which are 35 volt capacitors. So that's sort of like the bulk capacitance for that rectified AC waveform. And then it goes through this resistor, and there's a transistor, and some other components there, and that is actually creating the B+. So just clipping onto the fuse right here still keeps the fuse in play, and also onto the heatsink here just allows me to just bypass that. So that's what I've gone ahead and done right here, and you can see the ground lead is connected right there, and the positive lead is, like I said, connected to the fuse. Bypassing the bridge rectifier, as I did here, really didn't have much to do with actually getting this board working. The biggest problem was the horizontal oscillator, which we saw on my phone was running too slowly. Consequently, because the oscillator was running too slowly, the high voltage that was being generated by the flyback was far too low. But in addition, the flyback on a monitor like this actually generates several other voltage rails that are used by different parts of this circuit. And with the oscillator running too slowly, all of those voltage rails were really, really too low, which explains exactly why the picture on here looks so screwed up with the bowing and all those other issues. Back on this board again, the horizontal hold control, which adjusts the oscillator, is this one here. And I looked on the bottom of the board and I found that it goes over to this section of the board, which makes sense because this little circuit here is the video amplification circuit. It has nothing to do with horizontal hold. So the traces went over here. Well, looking at the way this was set up, it looked like this inductor here, this variable inductor, was in play. Now, I wasn't sure if anyone had adjusted that, so I took a tool, which is actually the one I'm holding right here, and I started adjusting that. And while looking at my phone, I could see that this absolutely had an effect on the frequency of the oscillator. And just turning that several turns actually got it running at the right frequency. And as I was getting closer to 15.7 kilohertz, the picture was getting brighter and brighter as the high voltage came up In addition, those geometry issues that we were seeing were going away as well. And now it just looks like this. It's basically completely working perfectly. Incidentally, from a power supply perspective, I'm giving it 18 volts at about 1.5 amps. I have the current limit set to that. It's drawing about 1.2 to 1.1 amps. So it's running at about 18 or 19 watts. Now I know that 18 volts is the correct DC voltage that this thing needs to run in before it goes through the regulator. So remember, the regulator needs to drop the voltage down to that regulated B+ voltage. The reason why I know it's 18 volts, because that is the perfect voltage where the geometry is looking good. Any lower, it starts to have issues, and I'll demonstrate here. So actually 17 volts looks okay. Okay, actually 16 volts still looks okay, but 15 volts it starts to freak out. And as I drop it down, notice it starts to get dimmer and have all sorts of issues here. So if we go back up to 16 volts, okay, so actually 16 volts, 16, 17 volts all works. But if I go up any higher than that, notice nothing really changes anymore, and that's because that voltage regulator is doing its job and it's keeping that B+ at the correct voltage for all the electronics in this board. Now, keep in mind I am bypassing this bridge rectifier on here, so there will be some voltage drop in there. So if I had the DC connected to the 2 pins here, I would probably need a couple extra volts on the power supply for it to work. And if you have AC hooked up to this, I would imagine 15, 16 volts is probably the right voltage, under load that is, for this thing to do its job. I called David Murray and I asked him about that adjustable coil there to ask him if he had twiddled with that that would have resulted in that frequency being off. And actually he did confirm that on the non-working board, which was this one, he did adjust that. If you are troubleshooting a CRT and like we were seeing those weird symptoms there, then using your phone with that Spectrum Analyzer app is an amazing way to tell if you're on frequency or not. I mean, that was extremely useful. I didn't even have to hook up the oscilloscope or anything to do any testing. Okay, so the broken board is completely working now. Had 2 problems. The IC was in backwards, and also the oscillator was quite far off frequency. Oh, there's something else that's kind of funny. When David swapped out that chip, he was doing it in front of his brother who runs the Geek Pub YouTube channel. And apparently his brother said, "Hey David, you have that chip in wrong or backwards." David's like, "Nah, it's not possible. This is definitely the right way it goes." And well, it turned out that it was wrong. Well, David said when he was swapping it out, he was so sure about the orientation of the IC because he said he compared the side that the writing was on to this board right here. Well, currently the Samsung part that's in there, the writing is facing me. So pin 1 is over to the left. And unfortunately with this board right here, it's actually the same. I can't read the brand of the IC that's in here. It just says Japan, but I can see the stripe for pin 1 and the dot towards the left. So I think David just might have been a little bit confused, and I don't know why, but he put that one in backwards. Luckily, no harm was done. The board is now working properly. Now let's take a look at this one, because earlier when I tried it, it didn't seem to work. There doesn't appear to be any kind of bleed resistor on these, so they do maintain some amount of high voltage when you turn them off. Incidentally, now that this one is working properly, it seems to generate about 11,000 volts. Okay, we're ready to go with the working board. I have the Spectroid up here, and it's zoomed in right on the part of the spectrum that we are going to need to look at. And I have the power supply up there set to 17 volts, 1.5 amps. I hooked up bypassing the rectifier as I did on the other one. Let me just double check. I got the ground lead on the board, ground lead on there, high voltage connected. The deflection yoke is connected. Everything looks ready to go. Here we go. Okay. Oh, wait. It's working. As you can see, it came right up. So I am not totally sure what was going wrong. Now you can see it, 15.750 kilohertz. What a very useful tool. Oh, what was that? Did you see that? I think we got a bad connection somewhere. When I banged on the table, it was kind of screwing up. I'm gonna use this plastic tool here and kind of poke things, see if anything acts up here. Okay, something's going on there when I hit the board. Yeah, we're getting deflection changes. Well, now it's really... Wonder what's going on. I wonder if there's like a cold solder joint on the bottom here. Just gonna check my connections are all solid here. Yeah, I'm not really sure. Everything looks totally fine. Let's power this back up again. Yeah, okay, I think I'm gonna power this off. The deflection is looking weird. I'm gonna check the solder joints on the bottom of this thing. It does look like some dodgy solder joints on some of these pots here, and when I poked on this one here, the picture kind of changed quite a bit. So let's just reflow all the stuff that looks a little dodgy. All right, I think I see the problem. There's a crack in the PCB right here. It goes from that pin on the flyback to that screw terminal. So kind of like how this corner was broken off, I think the same thing is happening here, and it might be breaking this ground plane right here. There's also this pin right here, which this trace here looks like it's breaking. So what I'm gonna do, it's funny, I just recently fixed that monitor, the Commodore 1084. I'm gonna grab the pen here and I'm gonna scrape away some of the solder mask across this, and I'm just gonna try to maybe solder some metal wires across it, solid core wires, just to reconnect that stuff. I'm gonna wear a glove here because I haven't been doing that, and I know that this fiberglass stuff can be kind of irritating to your skin. Yeah, that's broken right there. You know, I gotta say, I'm not really having any luck with this. Ideally, a Dremel or something to really clean that up. I think what I'm gonna do is I'm just gonna solder a thick wire between here and there for that one. And this is just the ground plane, so between there and any of this other stuff here on the ground plane. Sort of similar to what happened in this corner here. All right, there we go. I installed a few more bodge wires. I installed this wire right here. There's a little jumper link right there. That one and that one. The main crack seems to go just here and stop at that pin, but it might be moving over here too. I'm not sure. It might be like a scratch on the board or not, or a crack. I couldn't quite tell. So what I did is I just added this solid core wire there as well. So in case that is a dodgy connection, then it should stay solidly connected. I don't see any other issues. When I talk to David, I'm gonna tell him that he really needs to reinforce this board at least, maybe 3D print something that goes around the entire bottom. That way it's not just held up by these screws anymore, but is supported on the entire weight. In fact, something that probably supports the board here too, it's made out of plastic, of course, just where the flyback is would probably be good, because knowing arcade cabinets, they're probably pushed around like on their wheels, casters, and a lot of shock is gonna happen. So maybe rubber mounting the board, something like that. But yeah, this type of PCB material is just very fragile. Clearly this one has experienced some shock. So I'm gonna go on a limb and say that that problem we saw earlier, where there was no picture and no high voltage, was very specifically caused by the cracks in the PCB over by the flyback there. So let's reconnect the cables here. Let's give this thing one more test. Should be good to go at this point. All right, let's see. Current has settled. There we go. This is just turned. This doesn't look so great. I'd say that this potentiometer here for, what is this, vertical linearity? Oh, it's probably bad. Let me just drop a little deoxit on there. Here's my deoxit dropper. These are the old, oh, you know what? I shouldn't use deoxit, right? This is the carbon type of pots, or deoxit can actually damage them. So I'm gonna use the QD cleaner here. This stuff is, move my phone out of the way. I don't want that to be hit by this stuff. Let's just get these pots with this stuff. Okay, let's try now. There we go. Oh yeah, that's working way better now. Let's just turn the alignment of the yoke. Geometry on this one, not the best. So this is vertical hold here, which is obviously working properly. We have vertical size, and we have linearity. I'm not sure where this deflection yoke came from, which board, but you see we can adjust the picture up and down. And yeah, it's looking pretty good. It's a little curved at the top. This one hasn't been recapped, so it's possible that these caps are slightly problematic. Oh, that's a scratchy pot too. That's the horizontal oscillator control. Let me just spritz that. Yep, much better, no more scratchiness. That's looking pretty good. Let's hit this board a little bit. There's a little bit of something going on here on this edge. Let's see what's happening here. Is this a bad loose connection? I think it's like a, I don't know. Yeah, let's see if it's still doing it. No, stop now. I think that might be just a slightly dodgy connection on the yoke connector here. Probably is a little dirty. Okay, cool. Well, that is fixed as well. So broken traces, that is surely why we had no picture earlier when I first tried this up and it was just giving us like 500 volts. Clearly the flyback wasn't, I think one of those traces that was broken was probably going to the deflection yoke, because without the deflection yoke, you're gonna see like 500 to 1,000 volts maximum out of this. So I bet you that wasn't connected anymore to the flyback, so it wasn't able to create that resonance and all that tuning that's needed for the high voltage to work. And there we go, 2 repaired arcade boards for David's arcade machines. He will have a video on his channel soon talking about this stuff. Well, I don't know when it's gonna come out, but he told me he's been working on it forever. And the fact that these weren't working, well, at least that one wasn't working, was really throwing him for a loop. So as soon as he gets these back from me, he'll be able to finally finish his video. So if you enjoyed this video, thumbs up. If you didn't, you know what to do. Check the channel, subscribe, all that, you know, usual stuff. Thanks to my patrons. And yeah, that's gonna be that. Stay healthy, stay safe. I will see you next time. Bye.